Hello and welcome to a brief introduction on radians and degrees. So, we are all familiar with measuring angles in terms of degrees. So, you've talked in your previous math courses how in a circle, if you start anywhere on the circle and travel all the way around the edge of the circle, that the angular measurement there would be 360 degrees. So your math teachers might have said something like there's 360 degrees in a circle or something like that. Well, today we want to talk about another unit that we could use to measure angles, and that unit is the radian. So let's talk about what a radian is. Well, here we have the unit circle. Now, the unit circle is a circle that is centered at the origin, where the center is 0, 0 right there. And the radius of the circle is 1 unit. That's why it's called the unit circle. Now, what is the circumference of the unit circle? Let's figure that out. So if you remember, the circumference of a circle is 2 times pi times the radius. But for the unit circle, the radius is 1, so the circumference would be 2 times pi times 1, which would just be 2 pi. So this sort of basis is going to help us form our new way to measure angles, that we can use sort of this circumference of the unit circle being 2 pi is sort of the basis of a new unit of measurement that we're going to call radians, because it's sort of based on the radius of a circle. That's sort of where the name, the terminology comes from. So basically here, we're going to have this conversion factor that 360 degrees, which is sort of the degree measurement for all the way around the circle, we're going to say that that is the same angular measurement as 2 pi radians. And we're doing that because 2 pi is the circumference of the unit circle, and the unit circle is going to be very fundamental to our study of trigonometry. So this is sort of just something that it seems like I'm just making this up today, but we'll see sort of why these definitions make sense as we do more math. So probably if I wanted to make this formula a little bit simpler, if I sort of divided both sides by 2, you could also say that 180 degrees is pi radians. And, you know, sometimes people get confused thinking about radians because since it's defined sort of in terms of multiples of pi, people think that, you know, you have to measure angles in radians and they always have to have like pi in them or something like that. But that's absolutely not the case. Like I could divide both sides of this equation by pi, and I would get about there's about 57.3 degrees in 1 radian. So sometimes people will label radians with like rad or RAD, but oftentimes it'll just be sort of the number, and you'll know that it's in radians because when you're in degrees, you usually put the degree tick mark there. So if you're talking about an angle and you don't put that degree tick mark, then usually whoever's reading your work will assume that you're measuring in radians. So let's go back to the unit circle here. So if I wanted to sketch out a picture, I'm going to try to draw an angle of about 1 radian. 1 radian is about 57.3 degrees. So I'm just sort of freehand sketching this. So if I drew about that right there, so that angle looks like it's about 1 radian. That angle right there. I mean, I'm sort of freestyling this, but that looks like it's about 57.3 degrees. So angles, when you're measuring them in radians, like 1 radian's a pretty big angle. So you sort of have to adjust your feel for angles, like in terms of, you know, how big the numbers are. Like here's a good example here. This point right here. See how this is labeled as pi over 2. erase this and do another example here. So if I wanted to make a 90-degree angle, 90 degrees would be right there. Bam, I've made a 90-degree angle. So the measurement of that arc in degrees would be 90 degrees. But that's only pi over 2 radians. Now, why is that? Well, let's think about it. So, 180 degrees is pi radians. So if I wanted to figure out how many radians 90 degrees is, if I divided this middle equation here, both sides by 2, the left side would be 90, and then the right side would be pi over 2. And then in terms of what the decimal approximation is there, pi over 2, I think if you crank that on your calculator, it's about 1.57 or something thereabouts. I don't have my calculator in front of me, radians. So it just gets a little bit weird, and you just have to sort of adjust how you think about angles in terms of like their number. Like we're so ingrained with this 90 degrees as being a right angle, we just sort of have to get used to the fact that about 1.57 radians that makes a right angle. So let's look at some more specific examples. So if you want to think just in terms of like a straight up conversion formula, if you're converting from degrees to radians, just multiply by pi over 180 and you will get, this conversion will work out nicely. So let's say we had an angle of 210 degrees, and I wanted to know how many radians that is. I would just multiply the 210 by pi over 180 and reduce. So I'd have 210 pi over 180. So 210 degrees is exactly the same as 210 pi over 180 radians, but now let's sort of reduce this. I could reduce the 210 over 180, that's 7/6. So 210 degrees, that's 7 pi over 6 radians. Now again, you don't, like, this gets confusing to people because we've got this pi here, but you could think of this just in terms of the decimal approximation. So I could just literally, if I wanted to convert 210 degrees to radians, I could just multiply the 210 times pi and divide by 180 on my calculator and sort of round that off, get a decimal approximation of how many radians 210 degrees is. And you know what? I'm gonna pull up my calculator here and really quick because I wanna check that out. So if I want to figure out 210 degrees, how many radians is that? So it's gonna be 210 pi over 180. So 210 degrees is about 3.7 radians. There it is. So it's nice to think in terms of pi, because a lot of questions you're asked to think about, what the measurement of the angle would be in radians in terms of pi. But it's also nice to be able to, compute decimal approximations and make approximations and whatnot. So let's try converting from radians to degrees, try an example of that. So let's say I had an angle like, let's say my angle was, how about 7 pi over 4? 7 pi over 4 radians, and I want to know how many degrees that is. So I can just multiply that by 180 over pi, and I could just multiply straight across the 7 times pi times 180 and divide by 4 pi, but it's sort of easier if you clean this up and do some simplifications before you just like brute force multiply everything together. Like for example, these pi's would cancel, and I think it'd be easier to do 180 divided by 4 than to multiply the 7 and the 180 and then divide by 4. So I try to be as tricky as possible because I'm not the greatest at mental math, so I gotta try to make the computations small and manageable. So the 180 divided by 4 is 45. So then I can do 7 times 45 is 315 degrees. So 7 pi over 4 radians is the same as 315 degrees. So let's also just do a numerical example like that doesn't involve pi. Just crank it out on the calculator. Like, what if we had like 11 radians? Like, how big of an angle would 11 radians be? Okay, so if I want to know the degree measurement for that, I'm just going to multiply by 180 over pi. I'm going to grab my trusty TI calculator here and do 11 times 180 divided by pi. So 11 radians, that's a 630.3 degree angle. Great, so there's a couple of quick examples, and we'll be doing many more, practicing a lot on Khan Academy, and we're going to do great. Good luck.